Hello, this is Charlene. We're going to be talking about graphing linear equations in this video. There's a couple of things that are kind of helpful to remember about linear equations. First of all, a linear equation graphs like a straight line. And also, there's another piece of information. Linear equations are first degree equations. So what does it mean for a linear equation to be first degree? Well, it means that your variable x is always going to have a power of 1 because a straight line, is a one-dimensional object. So you can only measure one thing when you measure a line. You only measure its length. It's only got one dimension. And the way we recognize the equations is that the x will always have a 1 as its exponent or its power. Now, do we see the 1? No. Typically, it will just be listed as x with no power, but that means that the power of 1 is invisible. So this right here, this is our favorite slope-intercept form. It is a linear equation. This is our favorite form. It's like we're going to put a little heart next to that. Yeah, that's our favorite because it shows us what the slope of that line is. Does it go uphill or downhill? And how steep does it go? And we also have our y-intercept. So that's why we call it the slope-intercept form. Here are examples of lines. Y equals -3 is a line. 5x plus 3y is equal to 15. That is a line. And 4y is equal to 5x is also a line. And what they all have in common is that the x always has the invisible power of 1. Now this one also has an invisible power of 1 on the x, and we'll talk about that when we get to that slide. But we're going to start here in just a second with this one right here. This is the first one we're going to start with on this video. And problem says 5x plus 3y equals 15. Hence, solve for y, then write in the form y equals mx plus b. And their little hint is confirming that this is our favorite form of a linear function, is the slope-intercept form. It gives us a lot of information we need to solve or to graph linear equations. Okay, so we're going to do three things. We are going to convert to the y equals mx plus b, then we're going to plot the y-intercept, and then we're going to use the slope to finish. So the first thing I need to do here is 5x plus 3y is equal to 15. That y looks kind of funny. Let's change that. Okay, so the first thing order of operations says I need to get rid of is the 5x. So I'm going to do minus 5x on both sides of the equal sign. That keeps everything balanced and equal. So these will cancel out, and then I end up with 3y is equal to, I'm going to put the negative 5x in front because that matches my mx coming first, negative 5x plus 15. And then order of operations next tells me that I need to divide out that 3 on both sides of the equal sign. So divide by 3, divide by 3, divide by 3. Cancel, cancel. So y is equal to negative 5/3 x plus 5. So now I can easily identify the fact that my m is equal to the negative 5/3 and my b is equal to the positive 5. Okay, so the first thing, so I've converted it to the y equals mx plus b format. Now I need to plot my y-intercept. My y-intercept is the 5. So I'm going to go to my y-axis and I'm going to find a positive 5. So it'd be 1, 2, 3, 4, 5. So it's way up here. There is going to be my 5. And then I'm going to use my slope to finish. So let's think about this. So the negative 5/3, it's rise over run, but the negative is going to go with the 5. It actually means that I'm going to go down 5. That's what the negative means. The negative means I'm going to go down 5. And the 3 in the denominator means I'm going to go over 3. So I'm going to start at my y-intercept here at the 5 on the y-axis, and I'm going to go down 5. So I'm going to go down, 2, 3, 4, and 5, and then I'm going to go over 3. So I'm going to go 1, 2, 3. So that gives me my next point is way over here. And then I just need to connect those 2 points, and that will give me my line that I've been asked to graph. So there is my line, which matches this equation. This is a linear equation, and we just converted it to this version of the linear equation to make it easier to graph. The next equation they want us to graph is y is equal to -3. We can think of this as just simply as a y equals equation, which means it's only going to touch the y-axis. So let's go over here to the y-axis. Here's the y-axis, and we're going to go find -3 on the y-axis. So the y-axis is the vertical axis, and I'm going to go -1, -2, -3. There is -3, and it is only going to touch that -3 on the y-axis. It will never ever touch the x-axis. So it is going to be a horizontal line. It's going to be a horizontal line. So that is how we would graph it. And we can think of it just that simply. But I wanted to think about it in terms of our favorite slope-intercept form, because we said that linear functions always have a power of 1 on the x variable. Well, how is that? How can we figure this out? So let's think about the fact that this b that is in our slope-intercept form, the b is a constant. So the b is a constant. Well, is -3 up here a constant? Is it just a number by itself? It's not a coefficient. It's not in front of another variable. It is just -3. It is a constant. So that means that we can put that -3 in that b position where the b is a constant. So I can write that as y is equal to, and then I'm going to put -3 because the b is equal to the -3. So then we're also going to have, let's go ahead and put our x in there. Well, what is going to be the coefficient? What is going to be the slope of that x? Well, since up here we have no x, what would make the x disappear? What would make it turn into a 0? Well, a coefficient of 0. If it has a slope of 0, 0 times x would be 0, and then we would have 0 minus 3 is equal to -3. So y, we would end up with our exact equation. So the thing is, though, is that this is what it looks like if we expand it into the slope-intercept form. And as you can see, there's an x, but the power on that x is going to be the invisible 1. So this is still a first-degree polynomial. The x still has a exponential power of 1. It just happens to have a slope of 0 or a coefficient of 0, which causes it to disappear. And of course, that also tells us right there, what is our slope of a flat line? A flat line always has a slope equal to 0. 0 slope. Okay. Okay, the next equation is x equals 4. So we can think of this as an x equals equation, which means, practically speaking, that it is only going to touch the x-axis. So we are going to look for a 4 on the x-axis. So 1, 2, 3, and 4. There is the 4. And at that 4, we are going to find a vertical line. So we find a vertical line anytime it is an x equals equation. But I want us to quickly think about how can we convert that into y equals mx plus b. So we know that linear equations have an invisible power of 1 on the x. Well, there's an x, and it is going to have a power of 1. But we also are told that that x is equal to 4. So let's fill that 4 in for the x. It's a constant. So that means that the x is always 4. The x is always 4 because it is constant. It is constant. It is constant. Okay, so how can we rewrite that? We could rewrite that as y equals m times the constant of 4 plus b. Well, it is never going to touch that y-axis, right? The x equals equation is only going to touch the x-axis. It is never going to touch the y-axis. So we need to be aware of this concept that something does not exist. Any point on that y-axis is never going to exist on this vertical line passing through the x-axis at 4. So that means that we can say that this y in our slope-intercept form does not exist. Well, the b is a y-intercept, so it's also talking about a point on the y-axis. Well, it is also not going to exist. The b does not exist. So the thing is, though, is that we end up with m times 4. 4 is a constant. The x is always going to be a 4. So we have to realize that the slope also does not exist, because the only thing that is identified in this line is that x equals 4. X will always be equal to 4. Nothing is ever going to change that. So the slope does not exist as well. So this actually brings us to, do we know what the slope is of a vertical line? Well, a vertical line has a slope that is undefined. When something does not exist in math, we can say that it is undefined because it does not exist. So that kind of helps you understand how this is still a linear equation and how it actually can be understood in terms of the slope-intercept form of a linear equation. Okay, 4y is equal to 5x. And they've given us a hint. They say solve for y, then write it in the form y equals mx plus b. So we are going to take 3 steps to graph this linear equation. We're going to convert it to the y equals mx plus b, and then we will plot the y-intercept, and then we will use the slope to finish our graph. Okay, so let's go ahead and solve for y, which will convert it to the slope-intercept form. So 4y is equal to 5x. And I want to get the y by itself. So I'm going to divide everything on both sides of the equal sign by 4. These two 4's will cancel out. And then I end up with y is equal to 5/4 x. Okay, so at that point, does it look exactly like y equals mx plus b? Well, nope, it doesn't, because is there anything out here? Is there anything out here? No. So if there's nothing out there, what can we call that? What number can we call that? We can say that's plus 0, right? Because normally if it would be plus 0, anything plus 0 is just the number itself. So we can now identify, though, that this is y is equal to mx plus b. And we can identify our y-intercept. So our y-intercept is going to be in the b position, and it is going to be at 0. So that means we're going to plot a point at the y-axis. So here's the y-axis, but the y-intercept is going to be right at 0, at the origin at 0, 0. And now we're going to use our slope to finish. So we have converted it to y equals mx plus b format. We have plotted our y-intercept, and now we're going to use the slope to finish it. So my slope is 5/4. That is in the m position. M is equal to 5/4. So that implies a positive 5 implies that we're going to go up 5 and over 4 units. And of course, that coincides with that concept of rise over run. So from the y-intercept, I'm going to go up 5. So 1, 2, 3, 4, 5. And I'm going to over 4. 1, 2, 3, and 4. So I have another point right there. Now that I have 2 points, it is very easy to connect those two and draw our line. So there is my line for 4y is equal to 5x. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.